Welcome to Eden Guru students. In today's session, we'll be discussing common forces in nature, and in this, we will be discussing those forces which we will be using in mechanics, right? So, all of you are aware that if you go by the definition of a force, it is, you say that it's a push or pull. You have learnt it in your junior classes, right? Usually, you can ask two different questions when we are discussing about forces. One is, who is exerting the force and who is experiencing the force, right? And every object exerts a force or some kind of force in the other object or on the other object, right? So commonly the forces can be grouped into these four categories. The first one is gravitational force. The second one is electromagnetic force. The third is nuclear forces. And the fourth one is weak forces, right? Now, if you see the range of these four types of forces, the gravitational force has the longest range, right? Two different celestial bodies can apply gravitational force on each other, right? For electromagnetic forces, the range gets reduced by few meters also. For nuclear forces, it is only the periphery of the nucleus. The nuclear forces are very strong for very small range, which is close to 10 to the power minus 15, minus 10 meters, right? And weak forces are again comes into existence when we discuss about reactions between protons, neutrons and electrons. So there comes the weak forces, right? So let's see the gravitational force. If these are two bodies, right, having masses m1 and m2, one of the object will attract the other object towards it, and both these objects will attract each other. If the distance between these two objects is r, if the distance between the centers of these two objects is r, then the gravitational, the product of the masses inversely proportional to the square of the distance between them, and the force F is, the magnitude of the force F is equal to g m1 m2 upon r square. And please remember, it's an attractive force only. Force. Right? So if we, on the surface of the earth, say if this is the earth, right? If we place an object, so this is mass m, mass of earth is capital M, and its radius is r, right? This object will experience a force towards the center of the earth, and this force capital F is equal to g capital M small m upon r square. So please remember, whenever an object is kept on the surface of the earth, so if we draw the surface like this, suppose an object is kept on the ground, right? Suppose an object is kept on this ground, and this is a block which is kept on it, right? The mass of the block is m, then this block will experience a force mg, and this is directed towards the center of the earth. This mg is directed towards the center of the earth. So here you can see that since this object is very small and the surface of the earth seems to be flat to us, we can also say that mg is always perpendicular to the ground or the surface of the earth, right? So mg is directed towards the center of the earth, and it is also considered perpendicular to the ground right? Now let's discuss about electromagnetic forces. Let's discuss about electromagnetic forces. Suppose a charged particle is kept here, right? And another charged particle q is kept at a distance r from here. The force experienced by this charged particle is given as F, and it is equal to 1 by 4 pi epsilon naught QQ upon R square. This term is a constant. This term is a constant, right? As of now, we are not going to discuss this constant in length. We will discuss this when we will study about electrostatics, but this is a constant term, and epsilon is the permittivity of vacuum or free space, right? Here that force is proportional to the product of the charges and inversely proportional to the square of the distance between them, right? This is an electrostatic force, right? Similarly, magnetic forces can be there, but what is more important from classical mechanics point of view is we will be discussing some other forces which are electromagnetic in nature, but in mechanics we are using those forces, right? So electromagnetic forces other than the magnetic force and the electrostatic force, electromagnetic forces electromagnetic forces. First one is tension in the string. Tension in the string. Now, this tension T in the string is given as, this is given as T, right? This comes into picture when we try to pull the string, right? The bond length between the string changes and there is this stress coming into existence. And because of this stress, there is this tension. So, regarding tension, tension is always directed away from the pull. Now, what is this pull? Suppose I give you this example. Suppose this is a wall and this is the floor. So, as I wrote, tension is always directed away from the pull. Let's see this rope. This is a rope. One end of this rope is, and its other end is pulled by this man. Right? Now, can anybody of you tell me what is the direction of the pull experienced by this man? Please mark my words. What is the direction of the pull experienced by this man? It's along the rope and away from the man. So this is the direction of pull. I call this as tension. So the man was trying to pull this rope away from the wall, but you can see here that the tension in the rope or the pull experienced by this man is towards the wall. Please remember, the tension is always directed away from the pull, right? If we are pulling the rope towards us, right, the rope will exert a force on us, right? So that is the tension here. I will explain this tension to you by taking this diagram. This is a block of mass m and it is tied to this rope, right? This is the rope. Now, see the forces, or if we want to see the forces acting on this block, this is the ground, right? On this block, there are two different types of forces which are acting. The weight mg and the other one is the tension. See, this block is trying to pull the rope downwards, right? So the pull on this block or the tension acting on this block along this string will be, or along the rope will be away from it, right? So please remember, if we want to see tension acting on this block, it will always be directed away from the body or away from the object, right? Suppose, say this is the point, right? And what is the tension acting on this point? I am taking this point out. These are the parts of rope. So this is the tension T above it and this is the tension T below it. I am taking these two tensions to be the same because the point is at rest, right? So this is how the tension is drawn, or that this is how the tension acts on the body. But it will act only along it will come into existence only when there is a rope or a string attached to the body, right? So this is what is tension. Again, it's a type of electromagnetic force. Let's discuss the second force, which is an electromagnetic force but is widely used in classical mechanics. It is normal reaction. Now, when a block is kept on the table, this is a block and this block is kept on this table. Right? Now, this is a block which is kept on the table. Now, this block has mass m, right? See, this normal reaction is a force which every point on the bottom of this block will be experiencing because of every point on the table which is in contact with the block, right? This normal reaction will be spread on the entire surface of the block, right? But what happens is, since we have to draw it as a single force, so we say that the force experienced by the block because of the table is directed away from it and is perpendicular to the contact surface, right? This is the contact surface. This is the normal, and this acts in a direction perpendicular to the contact surface. Right? This same force, the contacts at the ground, and it will be downwards. This same force will be experienced by the ground and it will be downwards, right? So this is normal reaction. A spring force is the spring force. This is a block kept on a frictionless surface, and this is a spring which is connected to it. Right. Now, if we pull this, if we displace this block from this position, if we displace this block from this position, right, the spring gets stretched. Right? The spring is stretched. Let's X. Then the spring force block, then the spring force experienced by this block Fs is equal to minus Kx, where this negative sign suggests that negative sign indicates that the force is opposite to the direction of extension or compression. X is the extension or compression in the spring. X is the extension or compression in the spring. K is spring constant. And right, so this is how this, right. Now these are some of the electromagnetic forces which we will commonly use in physics, right? Here forces, and the fourth were the weak forces. We will discuss these forces. So we have discussed about gravitational forces and electromagnetic forces, and these two forces, that is nuclear forces and weak forces, we'll be discussing in modern physics, right? And in the next session we'll be starting with laws of motion. Till then, thank you very much. Goodbye.